Yeah, okay, I believe that we cannot wait any longer. So let's start. Really happy that you decided to join this session. My topic is Revealing Framework Fundamentals, Nest.js Behind the Curtain. And before we actually start, I'm going to quickly introduce myself. My name is Kamil. I came from Poland. Daily, I work as a full-stack software engineer from a company, with a company from San Francisco, so I'm working mostly remotely from Poland. You can find me on Twitter using this highlighted Twitter handle, and obviously on the GitHub. Beyond regular day-to-day work, I'm an open source evangelist and open source contributor. I'm a father of Nest.js, which is basically the fastest rising and probably the most popular recently framework for Node.js. And Nest is written entirely in TypeScript. But if you don't really like TypeScript, it's not a big deal. It's not a problem. You can switch to Vanilla.js whenever you want. OK, let's talk about Nest specifically. Nest is a framework. It is a framework for building server-side applications on top of the Node.js ecosystem. And during this talk today, I'm going to introduce you to Nest, just to show what Nest is for those who are not familiar with the framework yet. But also, I'm going to show you some TypeScript internals that made it possible to achieve what we have in Nest so far. So the first question is, who is familiar with Nest.js already? Please raise your hand. OK, like 30%, maybe 20% of the audience. Who heard about Nest but never use it? OK, almost the rest of the people. Nice. So just a few people that are going to hear about it for the first time today. So the actual number of stars on the GitHub is even more, is even higher than 10,000 stars. We just reached this value last week. Right now it's like 10,300, I believe. We need 100 stars to surpass Happy.js. So I suppose if everybody would just give a star right now, we would surpass this framework. OK. So Nest is a platform. What does it mean? It means that we provide a lot of things that come out of the box. We've got dependency injection, testing utilities, microservices support, WebSocket supports, a lot of various useful stuff. Generally, we are doing our best to empower developers and give them facilities to smoothly build progressive software. Additionally, we combine best practices. We integrate them to solve development challenges. And Nest is built on top of a few well-known design principles, which in turn properly applied to our software simplifies the process of creating scalable software. Also, we give right abstractions. These abstractions help organizing code and distributing responsibilities across different building blocks in an efficient way. We are opinionated, strongly opinionated. Nest is a complete set of tools that the developers can use to build extensible and large systems. We highly value consistency, coherence between projects, so you don't have to learn everything from scratch once you switch from one company to another one. And we are extremely reusable. Nest raises reusability on an even higher level due to its maximum compatibility with Express library, which is the most widely used library for web applications so far, and for example, Socket.io. Beyond that, Nest introduces terms like experience reusability and knowledge reusability. What does it mean? Because Nest is heavily inspired by Angular, but it doesn't mean that we address only Angular developers. If you use Vue, if you use React, if you even use jQuery, you can use Nest successfully. Moreover, it may resemble a bit Spring or ASP.NET. And you may ask why. Because we strive to make the learning curve as short as possible, so you don't have to learn everything from scratch. You don't have to waste your time. You can just use your knowledge, put it into the server side, and start creating beautiful things. All right, it's time for less theory, more examples, more building blocks. As building blocks, I'm referring to the controllers, providers, modules, and stuff like that. So the first building block that I'm going to talk about today is a module. At a higher level, modules are used to organize our code and to split features into logical units. So for example, you may have a users module, and everything related to users could be potentially inside users module. And every Nest application has at least one module, which is a root module used to bootstrap our application. So if you have Angular background, OK, one question, who has an Angular background? Nice, more than half of the people. It should be familiar experience for you. Specifically, the module holds metadata properties. It groups a few essential elements. First of all, we need either an entry point or multiple entry points to our application to somehow interact with our system. And in terms of the server-side applications, the entry point is either a gateway, a REST API, whatever. Basically, we are calling them controllers in Nest. And controllers are responsible for handling incoming requests to our application, as well as responding answers, responding with the actual responses. Then we've got providers. A provider is an instruction to the dependency injection system on how to obtain a value for dependency. It might be a class decorated with injectable decorator, it might be a factory, or just a simple value bounded to the container. Another property, imports. It's a list of modules that should be folded into the module. In simple terms, it's like every exported provider is going to be available in the module which imports this particular module, and you can successfully use it. And the last property, exports. It is a sort of public API of the module. So you can explicitly define which providers should be private, encapsulated inside a module, and which should be publicly available from the outside. OK, more code. I prefer more code than the simple theory. This is a typical Nest module. As I said before, if you are familiar with Angular already, that should be a familiar experience for you. So we've got a class with module decorator on top of it. We've got some metadata properties. There is no declarations, like in Angular, for example. Instead, we've got controllers, because we don't have this all HTML template stuff. And we've got a class. And class is used to track the module inside our system. Very simple way. Eventually, modules form a graph data structure. In this particular example, all relations are unidirectional. Sometimes they might be bidirectional, though. So I hope that everybody is familiar with a graph data structure, but just to ensure that everyone is on the same page. A graph is a representation of a set of objects connected by edges, and all these points are termed as vertices. Also, all these edges might have weight, but it's not really important in terms of the Nest modules. So taking a step back to our modules visualization, it is actually a directed graph structure in which each vertex represents a single module. It leads us to a conclusion that each module is a singleton, which is partially true, but it's not always the case. It's slightly different when it comes to the dynamic modules. So each vertex is really just an instance of the module class, which holds some metadata inside that enable us to create injection scopes. I know that it's quite difficult to follow with that. But before we achieve this thing, like this class that represents a module, we have to go through a small process. So firstly, we have to pass the root module to the metadata scanner, which is going to recurrently look up every existing module, pass it through a compiler, and the compiler eventually is going to produce us an instance of this class. So we are putting the root module, which is going to analyze the whole tree, the whole graph, actually, of modules, and produce these instances of the class module. All right, another building block, provider. As I said before, a provider is an instruction to dependency injection system on how to obtain a value for a dependency. But anyway, let's dive into the code once again. So this is the ordinary provider in Nest. It has a injectable decorator on top of it, same as in Angular. And HTTP service is a required dependency, which should be eventually injected through a constructor. And Nest is going to handle that everything under the hood. So you don't have to worry about anything. You don't have to manually create cat service, put HTTP service instance. Everything is going to be solved underneath. But from the technical perspective, given this class, how do we know that cat service really needs HTTP service? What if it needs another argument? What if we want to inject HTTP service at position number 1, as well as, let's say, cat's repository, our data source representation, I don't know, maybe representation of our SQL database? How does it work? So generally, we are using powerful TypeScript capabilities, reflection capabilities here. In order to access these two types, we have to reflect design param types metadata key provided by TypeScript during the transpilation process. So this is a sort of metadata reflection API, which is used by Nest under the hood. Using metadata reflection API, we can get constructor param types. So what we have to do, essentially, we have to put design param types as a first parameter of this function, and our class as a second parameter, in this case, cat service. And you can see that it's going to return us an array of types that we can use to indicate what dependencies are required in the actual cat service class. It's a very, very useful thing. So right now, everything becomes very simple. We've got an array with 2 elements. We know that at the position number 0, actually, we should take and put HTTP service inside a cat service, and the second parameter is going to be a cat's repository. And now it's very simple. We just have to perform a lookup through the modules, find an instance, create a new one, and that's it. But reflection API challenges. It would be too good if everything was so simple. It's not, because there are problems on the road which we can face very often. First of all, let's talk about interfaces. So this is our previous example. We are going to switch from HTTP service to the iHTTP service interface. Regardless of the naming convention, I personally don't use I before each interface name. Anyway, I've used iHTTP service just to clearly indicate that it's not a class, it's an interface right now. Now let's reflect our constructor metadata again, same as before. And what? It turns out that we have an object. Instead of iHTTP service, we've got a regular object type. And this type does not bring any intrinsic value. We cannot do anything with that because we may have so many interfaces across our whole application, and all of them are going to be represented by the same reference, by object. So the reason is that interfaces do not exist in a vanilla JavaScript, and therefore TypeScript is not able to provide us with useful information about iHTTP service. We cannot distinguish interfaces. They are not going to work well together with Nest. And same applies to Angular, actually. Another difficulty, generics. Again, let's have a look at our cat service. We are going to switch from an exact cat's repository class to generic repository with a cat specialization. Just like that. So now we have a repository specialized for cat entity. We may have a one class, a generic class. We can use it across the whole application for each existing repository. But let's dive into the metadata stuff again. You can see that we lose knowledge about specialization. Now, the metadata variable is an array with 2 elements, HTTP service and repository. What about cat? What is a cat? How do we know that cat service really needs a repository of cat, not any existing repository in our application? What if you have more repositories? We cannot associate them together because we lose the metadata about the generics. And the last difficulty, circular dependencies. Let's say that we've got a cat service, which for some reason, I don't know why, injects doc service as the only dependency through constructor. And we've got a doc service, which also injects, but cat service instead. So cat service needs doc service, and doc service needs cat service. What's now? We reflect the metadata, and we can see that the metadata is going to be undefined. Doc service is undefined. Why? Because we've got a circular dependency between classes, and it's unable to provide us with useful information about the type, because it's going to be an infinite loop. At some point, they have to replace it with undefined. We cannot track it. But Nest gives you some useful tricks to solve this issue, but I'm not going to cover it just right now. Custom providers. There are a lot of scenarios when you might want to bind something directly to the Nest inversion of controller container. For example, external libraries. If you use a JVT package or whatever, you want to inject it through constructor instead of hard coding the library inside a class, you can create a custom provider. What else? Pre-calculated values. Configuration objects based on the current environment. In this case, we can just use a custom provider. And this is a custom provider. It's a typical literal JavaScript object with 2 or 3 properties. The first one is provide, which is our token that we are going to use to track our provider across the application. And the token might be a string, it might be a symbol, or it might be a class. If it's a class, it means that we can override the implementation of this class. Like in the testing environment, instead of performing a real HTTP requests, I would like to use value, which is an instance of mock HTTP service. So we are not going to really call any, external API. Instead, we're going to mock all outgoing requests in a very simple way. So the second property is use value. So we can create a value immediately in place. We can pass the options object, we can pass an instance of the class, everything. Another way is to use a factory. And factory is just a simple function, which might be either synchronous or asynchronous. So you can return an instance, depending on some different providers. You can make this function asynchronous, so you can have a promise, which resolves to an instance. For example, connection to the database is a good example. If you want to inject connection into your providers, it's probably going to be a good decision to use an asynchronous factory. And the last one is to use class. So when you use class, it's going to leave the responsibility to the framework itself, and framework is going to instantiate this class by itself. How to use custom providers? In order to use custom providers, we have to use inject decorator. Inside a parenthesis, we have to pass this token. So as you can see, it's just a string, HTTP service. And here, we have to pass the string between parentheses. Also, each dependency might be optional. So if something is not very crucial for this particular scope, or this particular context, for the cat service, we can mark it as an optional value. And if this provider does not exist, is not present in this module, it's not going to break the whole application. It's just going to move forward and pass undefined in this value. OK. Third element, controller. Controller purpose is to receive specific requests for the application. The routing mechanism controls which controller receives which requests. Frequently, each controller may have more than one single route, and different routes serve different actions, like create records, get records, update records, and so forth. So this is a very simple diagram which illustrates the flow. We've got a client which calls our application. We've got a request incoming to the controller, and the controller responsibility is to return an answer, like JSON payload, whatever you prefer. General approach. Basically, if you take most of the existing libraries, like Happy.js, Express, Fastify, whatever, it's going to look like that. So what you have to do is create an application instance, for example, Express. You have to create a router, which is going to be our controller. You have to explicitly call the post method for, let's say, post requests through the network. You have to pass a path as a first parameter. You have to pass the callback with 2 or 3 arguments. Inside, you have to access the request body without any typings. And you have to call the send or JSON method to send a response back to the client. And at the end of all this stuff, we have to indicate that we want to use recipes controller. So it's a very, very imperative style. Quite tough to test due to the callbacks, which leads us to a callback hell eventually. And it's not very readable, I would say. Let's talk about our approach. Instead of this imperative style, we prefer a declarative one. So we are using decorators. Instead of creating a router manually, you can just put a decorator on top of the class. You can pass a prefix for each root defined inside between the parentheses. It might be a string. You obviously don't have to do that, but it's useful in the majority of cases. Inside the class, you can define an endpoint. Again, declaratively. Just put the decorator on top of the method. It might be a post, get, patch. What do you need in this place? And in order to access, for example, body of the request, we again have decorators. So we can have a query decorator, param decorator, or body decorator. And just normally, we can return an answer like a just simple value from the function. And the function obviously might be asynchronous or synchronous. Guards. Guards control the router behavior. You can determine whether the request processing should continue or not, depending on some business-specific requirements, application-specific requirements. Let's have a look at the diagram. We've got an incoming request to our application. Before the request may hit certain root, for example, before the request may hit certain root, each guard has to check if this particular request should be allowed to proceed. So, for example, extract the authorization headers, validate the JSON web token inside, whatever authentication strategy you use. So imagine that you have a user's endpoint or whatever. User's endpoint is quite sensitive in terms of the typical applications. So you have a user's endpoint, and it contains very, very important data because it's going to extract your users table from the database and return it to the user. And this endpoint definitely should not be publicly visible for everybody. So you would like to restrict an access to it, maybe only for super admins or administrators of the system. So we can create an authentication guard and reuse it across the whole application. And obviously, each root may have 1, 2, 3, or even more guards, depending on what you really want to achieve. Let's dive into the code again. So this is a simple authentication guard. Obviously, without a body of the method, we are just simply immediately returning true value, which means that we allow us to proceed. If you return us a false value, we are going to throw an exception, and the request won't be able to access the handler. So this is a class. Again, injectable decorator on top of it. So we indicate that this class is able to inject dependencies to the constructor. It implements canActivate interface, which forces us to implement canActivate method, which in turn has to return an answer either synchronously or asynchronously. So it might be a Boolean, it might be a promise, which resolves to Boolean, or it might be an observable, which wraps Boolean. Additionally, we've got one parameter, execution context. And execution context may vary depending on the type of the application which is built right now. In REST APIs, execution context contains request-specific details, while in the microservice, it contains a data sent through the network. In WebSockets, it's going to have a reference to the client and data sent through the network as well. Additionally, execution context has even more powerful stuff inside. It has a reference to the method, which would be eventually executed if we return true value, and also it has a reference to the class which declared this route. So I know that it might be quite complicated, so just to explain it, let's say that we've got our users controller, which is a class, and inside this class we've got one method, create, like in our previous example. One class, one method inside. If authentication guard is running for this particular create method inside a users controller class, execution context would have reference to the users controller class and reference to the method, which is going to be executed, so create method, reference to this class and the method inside, which gives you very powerful capabilities in terms of the reflection system and metadata stuff. Generally, Angular, for example, has a router module where you can indicate which guards shall be evaluated once someone wants to navigate to the target component. In Nest, we don't have router module though. So we can bind your guards in a few different ways. Using useGuards decorator on top of the method, using useGuards on top of the class for each route defined inside, and obviously you can set up a guard globally for each existing endpoint. And the last element, interceptor. Interceptors inspect and transform HTTP requests from the client to your application. The same interceptors may also inspect and transform responses on their way back to the client. So again, simple diagram. The client performs a request to our application. We need to reply, send an answer. And interceptors may enhance incoming requests to our application, as well as enhance an outgoing response to the client. So you can attach some properties. You can, based on the response, modify HTTP headers. You can perform side effects. You can dispatch an event in the background. Anyway, let's dive into the code once again. Interceptor is just a simple class, again, with injectable decorator. It implements Nest interceptor. For example, in Angular, you have HTTP interceptor. But in Nest, we've got Nest interceptor. Why? Because interceptor might be used across each existing transfer strategy. Inside WebSockets, inside GraphQL, microservices, REST APIs, everywhere. And this interface forces us to implement intercept method, which returns an observable. This observable is just an execution flow. So we've got two parameters inside. Our well-known execution context, which is actually the same one as in the guards example, and next observable stream, which represents the next interceptor in the chain of interceptors. So this is an execution flow. We just went through a few Nest essential application building blocks. Well, it's still nothing, to be honest. There is so many things that Nest gives you out of the box. Pipes. A pipe takes in data as an input and transforms it to a desired output. Generally, you might notice that in your service application, you desire many of the same operations repeatedly. For example, the data sent through the network has to be validated beforehand. Sometimes you may want to cast the string value to the integer value all the time. And pipes in Nest are useful when it comes to such operations. And again, very simple example. Pipe is a class. with injectable decorator, which implements pipe transform. And we've got a transform method inside that takes input data and metadata, 2 parameters. Obviously, the value, type of the value, might differ depending on the place where you actually use your pipe. But let's talk about argument metadata. So it turns out that argument metadata is a simple JavaScript object with 3 properties, just 3 properties. Let's take a step back to our example from the controller section, like recipes controller. You can see that we've got a post endpoint inside the create method, and our argument metadata is going to contain 3 properties: type, data, and metatype. 3 properties. Metatype is create recipe DTO reference, which again enables very, very powerful reflection capabilities. You can work on top of the expected type in an endpoint. We've got a data, which is basically a data passed between parentheses. In this case, it's going to be undefined because we didn't pass anything. And type, which is going to be a string, which indicate if the pipe is running for a body, for param, or query parameter. But type and data, they are very easy to follow, actually. The most important thing is metatype. So how do we know that create endpoint really needs create recipe DTO? Let's talk about reflection once again. So again, we can use our reflection metadata API to extract the type, the param type, used inside the method. So we have to call reflect get metadata. We have to pass this metadata key, which is a constant value. We have to create an instance, which Nest is doing actually underneath, so you never have to do it manually. And we have to pass the name of the method. And the name was create, so we have to pass create here. And it's going to return us an array with 1 element, because only 1 parameter is present in this function, which is create recipe DTO. And it's very powerful because we can, for example, get the data which was sent through the network, compare it with an expected schema, and perform a validation. And now we can enable validation across the whole application with a single 1 validation pipe. Another thing, we are giving you exception filters to filter out exceptions, attach your business-specific exception handling logic, allow interacting with the low-level API of either Express or Fastify. Swagger. So it always comes to this point when your front-end friends or mobile application friends are going to ask you about the API specification. Please let me know what endpoints can I use in order to interact with your system. And backend people do not really want to do it manually, wasting time on the documentation. So we've got a Swagger module, which is going to take your application. It's going to perform a sort of tree traversal algorithm, create the full documentation based on the metadata of your application. And you basically are going to have a list of each endpoint created automatically. And if you put some additional decorators on your DTOs, like create recipe DTO, you can see that it may have properties properly reflected automatically by the Swagger module. So you never have to write it on your own. You can just put an application instance to the particular method, and we're going to take care of the rest. WebSockets. So as I said before, we always support WebSockets, so we are able to create real-time web applications. And underneath, we use Socket.io. But the reason is that we use Socket.io is because it's well-known, popular, stable, used across many production applications. But the truth is that it's quite slow. So if you don't want to use Socket.io, it's not a big deal, because you can write an adapter. And for example, Nest provides you an adapter for a different library, which is much faster than Socket.io. You can just use it without switching, without changing anything in your code. Because everything is wrapped up with this abstraction layer, which is going to take care of everything under the hood. So in order to subscribe to the message that comes through the WebSockets, the only thing that you have to do is to call subscribe message and put the name of the event between parentheses. And regardless of whether you use Socket.io or native WebSockets, whatever, it's going to work in the same way, always. Microservices. So by default, Nest supports NATS messaging platform, Redis with its powerful publish subscribe feature, MQTT, so many different transfer layers. But also you can always port your messaging platform like Kafka or whatever you need, and it's going to work in the same way because, again, we've got an abstraction layer. And this abstraction layer is communication by patterns. So you can use message pattern, put a pattern between parentheses. It might be an object, it might be a string, symbol, whatever. And everything is going to be solved under the hood. So we are going to take this pattern, bind it to your transfer layer, and then perform the routing mechanism, which is going to take this value, compare it to this to send through the network, and delegate it to the appropriate method. And obviously, as I said before, we support GraphQL. So if you like GraphQL, you want to use GraphQL, you can easily use Nest for this purpose. We have a Nest.js GraphQL dedicated package, which exposes few decorators, which means that you can declaratively build your resolvers map using resolver decorator, query decorator, mutation decorator. And again, we are taking your application and we are going to sort of compile it to a compatible version for the Apollo GraphQL library. Developer workflow. The developer workflow is also very important when working on a large product. And thus, we have created Nest CLI. And Nest CLI exposes a few essential commands, like Nest new to quickly scaffold your project, or Nest generate to smoothly generate all your building blocks, including controllers, modules, pipes, guards, everything. And guess what? Nest CLI is based on an excellent Angular schematics. Nest has a dedicated Nest.js schematic package, which is used by the CLI underneath. But also, if you, for example, do not want to install Nest CLI, you can use Nest schematics together with an Angular CLI. They are compatible with each other. And now I should probably talk about latest news, but I'm not going to do it because I would like to switch to a real coding session. What I'm going to show you, I basically think that it might be more interesting for people who comes with a Nest background. But for the rest of you, I hope you will enjoy anyway. OK, what about the font size? Is good enough? OK. So this is a typical Nest application, or maybe even like that, generated through Nest CLI. It's a bootstrap file. You've got a few lines of code. The only thing that you have to do is to put application module into the create method. You have to indicate a port that we are going to listen to, and that's it. And this is the app controller, essentially what I was talking today. So we've got decorators to create a controller. We've got decorators to create endpoints. We've got dependency injection, so we can easily inject application service, which is just a simple class with injectable decorator on top of it. Very simple mechanism. And there is a lot of people that complain that Nest is object-oriented framework. Like, I prefer functional programming. That's why I'm using Express. That's why I'm using Happy.js. Because here, everything is wrapped up with this class stuff. I need to create classes. I cannot work with functions. What about the higher order functions? What about the closures? It's not present in Nest. Well, not really. Because Nest supports mixins. So if you ever tried to create, let's say, CRUD controller for a basic create, read, update stuff, you probably came up with stuff like that. So we can create a CRUD controller. Maybe let's create a directory for this. And you probably came up with something like that, like CRUD controller. It might be not, we don't even have to use a controller. And then you would extend this class by any other existing controller in your application. But this solution is definitely not the best one. And what I'm going to show you is not a part of the documentation right now, because I personally didn't have enough time to explain it in detail, because it's a little bit more complex. So what I'm going to do right now is to switch from a class to a function. And inside, I'm going to define a class, which is CRUD controller host. And I'm going to return a CRUD controller host directly from this function. Let's not care for it for now. And what you can do is that you can pass here parameters to configure your CRUD controller from the outside of the application. How does it work? So normally, if you'd have just a CRUD controller that you can extend, you would always have to pull all these things up in the tree, in the dependencies tree. So I'm gonna, first of all, show you, let's say, maybe let's switch to first CRUD controller. And let's say it's gonna have private read-only CRUD service, which is gonna be an interface, CRUD service, just like that. And now, if we want to extend this CRUD controller, we would have to always do this, which makes it very cumbersome, very tough, because every time you have to call this super method. And if you have more than one dependency, it might be even more confusing more and more. And the problem is that, another problem is that we cannot pass parameters to CRUD controller. We cannot determine the behavior of the CRUD controller. So, for example, we cannot set a prefix here, like that. We cannot do that, because we cannot pass arguments. What else? Let's imagine that we have a create method here. Okay? And depending on the type of the controller, create method takes different DTOs. Like in this case, create entity DTO. The problem is that we do not know type here. So the validation pipe, which is built in Nest.js, is not going to work. It's not going to work because we do not have information about type. what might be used here inside. So how we can solve this problem? Again, switching to a function which takes parameters. It's a host class. Inside, TypeScript is going to complain that this type is, like, we are using the private class, but we can just cast it to any or whatever, or we can provide an interface with a new function defined inside. We are not going to focus on it. And take a look right now. What if we don't want to call this super every time? There is a solution for that. What if I can pass here a service, like for recipes controller, I'm going to pass recipe service. I'm going to take the service, and instead of doing it like that, I can, for example, do it in this way. And now I can remove that part. And now we don't even have to write constructor. Oh, we don't even have to write constructor. We don't have to call super every time. But CRUD controller may have a service, may have a pagination helper, may have some helpers, repository, whatever. What if inside the application controller, I would like to use something else? So instead of injecting only 3 dependencies, I would like to inject 4 dependencies. So inside the application controller, I would like to inject something else, like HTTP service, for example. And now it's not going to work, because again, we have to call super with a CRUD service, so we have to put another dependency here. Like, let's do it actually. Only service app service. Actually, without finding this. Yeah, just like that. Which doesn't make sense, because if you have a huge application and you always have to call super method, it's so complicated, and you can always, mix the indexes, stuff like that. So there is another feature which is available in Nest since a latest minor version. Instead of using a controller for injection purposes, you can take this stuff and you can put it here. And then you never have to call super again. You don't even have to inject this service here manually. Everything is going to be solved here inside. Injection-based, property-based injection is not always a good decision, but in this case, it might solve so many problems that you can face during the development process. So if I cast it to any, just to not see all the time this red line, now it's fine. It's OK. We can use here like CRUD service, create, fast create entity DTO. Let's make this async. And inside a CRUD interface, we can define a method, which takes DTO, for example, just like that, and promise of something. Let's say just any for now. Now, using this mixing strategy, we can create a very generic CRUD controller, as well as CRUD service, put all this stuff together, and then each controller is going to just look like that. one line of code. So if you create a very generic CRUD controller, which is a mixin, which takes parameters, which customize the behavior of the class, you don't have to do anything else except extending the class returned from the function. But if you want to add additional logic, maybe a typical CRUD stuff is not good enough for you, it's not a big deal. It's not a big deal because you can always define this method here, like create, fulfill an interface, and here call super create, like awaited, for example, and perform the rest of the stuff here. So this is a very, very interesting mechanism. Mixins are not explained in the documentation yet, but they give so many reusability advantages that you can use inside your application, and it's gonna work really, really well. So just to finish this live coding session, I'm gonna very quickly create an interface, which is gonna be like interface CRUD controller. Let's say that our CRUD controller is gonna have always a create, which takes DTO as previously, because here we have built a service. It's the generic, like that. Promise, let's say any. And now, instead of returning any from our function, we can return a type, which is a CRUD controller. And it's gonna be like any, for example. Okay, like that. So we take a service, which is an interface. We return a type, which is gonna eventually create a CRUD controller. And here, now we need to create a method here. DTO, blah, any. Still complaining, whatever. Yeah, whatever. What it gives us that we have a strong typing here. It means that now, if we call supper, we have a type IntelliSense, and we know that our CRUD controller contains create method inside. And we can do the same for all this stuff like find all, find one by ID, let's say. We can create a whole bunch of methods just right here and then extend it in every place in our application. So mixins help you achieve things that rather comes from the functional nature of programming rather than object-oriented, but they are also available in Nest. And the last thing that I would like to show you in terms of the CRUD controllers, CRUD services. As I said, CRUD controller is just only a tip of the iceberg, because you can create a CRUD service as well. You can take all this data. Instead of creating CRUD controller, you can create a CRUD service. And the same applies to the services. So you can create a CRUD service instead of returning a CRUD controller. You can return a CRUD service, create a mixin for services, create a mixin for controllers, and use them across the full application. So you will never repeat yourself again, never. And you will have a full customization ability, because you can basically pass everything here. You can pass a create DTO, maybe not in the service, but here. You can pass a create DTO, so we can pass a reference to the create DTO. You can pass a path, which then you can use here. Like prefix, for example. Maybe prefix is a better way. You can pass everything. You can customize it inside, create a class, return a class, and that's it. We don't have find all, we don't have find one, like these two methods, but who cares? All right, so switching to the presentation again. I would like to spread a few latest news about Nest. First of all, StackBlitz. Who is a StackBlitz? Please raise your hand. Anybody? Nobody? Wow. So StackBlitz is an online IDE. It's like Visual Studio Code in the browser. So you can take your, for example, Angular application or React application. You can put it in the browser. You can run it directly through the StackBlitz, which looks very, very similar to our real Visual Studio Code. And what else? In the near future, it will be entirely compatible with Nest framework. So you will be able to take Nest application, server-side application, put it in the browser, and execute it from the browser, so you can share the link to someone else. Hey, let's see, this is my server-side application. I'm running it directly from the browser, and it's going to work like a charm. But it's just a future. I don't know when. But surprise, Code Sandbox did the same, and it's available already. You can get into the Code Sandbox. You can create your sandbox, your project, and you can run server-side application directly from the browser. So if you navigate to this URL or you take a look into the official website, you will see the example with a Code Sandbox. So you can now write server-side applications in the browser, and they are going to be deployed directly to Lambda functions. OK, lastly, Nest is open sourced, meaning that we are totally driven by the community. And therefore, I encourage everyone who shares similar ideas to join this little revolution. Pull requests, comments, everything is very welcome. We would love for you to contribute to Nest and make it even better than it's today. And there is a couple of companies and almost 83 backers so far who decided to support us with their donations. A big thank you to all of them. Thank you for your attention.
Thank you.
And one thing, if you've got any questions, I'm going to hang around in this place for questions. So just go, join me. And
we have time for one question.
Oh, yeah. So, any questions? Who is going to be this one?
OK, thank you. How about pipes, guards, and other stuff at CRUD controller?
OK, I would have to switch to the real coding session again. But the truth is that you can pass even guards as your parameters, and you can use guards decorator, pass parameters between parentheses, and it's going to work like a charm. Very, very nice. What I did, for example, from our real life example, from a real application, we've created a CRUD controller which takes a permissions map, which is an object for with few properties: read, update, write, and stuff like that. And we indicate that read is available for everyone, while update is available only for admins. So we are passing into the CRUD controller an object with these properties, with permissions properties. We are using decorators, like rows decorator, to indicate that this method should be allowed only for admins. And everything is solved inside the CRUD controller. We've got an auth guard binded on the top of the class, so we don't have to worry about anything.